Recall that a thermal power plant burns fuel to boil water into steam. The steam spins a turbine, and the turbine makes electricity. Because there are so many stages, a large part of the energy is lost as heat, and it also causes pollution. It is only about 40% efficient. A galvanic cell, as we saw, turns chemical energy straight into electricity in a single step, with no heat or steam in between. Though it is far more efficient. When we apply this same idea to a fuel, we get a fuel cell. A fuel cell is a galvanic cell, but with one difference. In it, the fuel and the oxygen are fed continuously to the electrodes, and the product that forms is removed continuously. So it keeps giving electricity for as long as the fuel is supplied. Galvanic cells designed to convert the energy of combustion of fuels like hydrogen, methane, and methanol directly into electrical energy are called fuel cells. The most successful fuel cell uses hydrogen gas and oxygen gas to make water. It was used to supply electricity in the Apollo space missions. Here, the water that formed was used as drinking water for the astronauts. Inside it, hydrogen gas and oxygen gas are passed through porous carbon electrodes into a concentrated sodium hydroxide solution. To speed up the reaction, catalysts such as platinum or palladium are added to the electrodes. With the cathode, oxygen gas accepts water and electrons to form hydroxide ions. In words, oxygen gas plus 2 water plus 4 electrons gives 4 hydroxide ions. With the anode, hydrogen gas combines with hydroxide ions to form water and electrons. In words, 2 hydrogen molecules plus 4 hydroxide ions gives 4 water plus 4 electrons. These electrons flow through the wire and give electricity. Binding the two together, the overall reaction is very simple. 2 hydrogen molecules plus 1 oxygen molecule gives 2 water. The only product is water, and that is the beauty of the fuel cell. A fuel cell keeps working for as long as the fuel is supplied. Its efficiency is about 70%, while a thermal plant is only about 40%. Because the product is just water, there is no pollution. Corrosion slowly coats the surface of a metal with oxides or other salts of the metal. The rusting of iron, the darkening of silver, and the green coating on copper are all examples. This causes huge economic damage. In corrosion, the metal loses electrons and is oxidized. For the rusting of iron, both water and air are needed. The most interesting thing is this. It is really an electrochemical process, in which a tiny cell forms on the surface of the iron itself. But one spot, iron gives up electrons and becomes the iron 2 plus ion. This spot acts as the anode. In words, 2 iron atoms gives 2 iron 2 plus ions plus 4 electrons. The standard electrode potential of iron is minus 0.44 volts. Those electrons travel through the metal to another spot. There, oxygen gas accepts hydrogen ions and electrons to become water. This spot acts as the cathode. Words, oxygen gas plus 4 hydrogen ions plus 4 electrons gives 2 water, with a standard electrode potential of 1.23 volts. Hydrogen ions here come from carbonic acid, formed when carbon dioxide in the air dissolves in water. Combining the reactions at both spots gives the overall reaction. 2 iron atoms plus oxygen gas plus 4 hydrogen ions gives 2 iron 2 plus ions plus 2 water. Standard cell potential is 1.67 volts, which means this is a spontaneous reaction. The iron 2 plus ion formed here is further oxidized by oxygen in the air into the ferric state. This is the brown rust that we see. It is hydrated ferric oxide. Preventing corrosion is very important. It saves money, and it avoids dangers such as bridges collapsing. The simplest way is to keep the metal surface from touching the air. We can do this by painting it, or by coating it with another metal such as tin or zinc. There is also an electrochemical method. A metal more reactive than iron, such as magnesium or zinc, is attached to the iron. That metal corrodes itself and saves the iron. His is called a sacrificial electrode. Let us recap. A fuel cell converts a fuel's energy directly into electricity very efficiently and with no pollution. Corrosion, on the other hand, destroys a metal through a cell that forms on the metal's own surface. There is a beautiful connection here. Using renewable energy like solar power, we can electrolyze water to make hydrogen, and that hydrogen can be used in a fuel cell to give electricity. Then it becomes a completely clean and renewable energy source. This is the hydrogen economy. With this, the chapter on electrochemistry is complete. Thanks for watching. Like and subscribe to Vidyarthi. Electrochemistry, last 12 chemistry in English.